Introduction. An operating system OS manages hardware resources and control the process execution. CPU scheduling is a vital part of the OS that decides the execution order of the processes. Efficient scheduling improves, it will improve the CPU utilization, response time, and the expressions. Different scheduling algorithms exist, such as first come first serve, SJF, SRTF, priority schedulings, and round robin, etc. In this project, we focus on first come first serve (FCFS) scheduling, where the process arriving first and executing first. Objectives: to design and implement a FCFS scheduling simulator to, to accept dynamic arrival time and the bus time as input, to calculate and compare the process performance metrics. We will calculate here the waiting time, turnaround time (TAT), and the response time if considered. Okay. To analyze the performance using three different data sets, to observe CPU behavior and identify the issues like conveyor effect, to evaluate the whether FCFS is suitable for real-time system or not. Next, problem statement. Efficient CPU scheduling is essential for process execution and overall system performance. FCFS, first come first serve, is one of the simplest scheduling method, but it performs may vary under the different workload. There is a need to design and test an FCFS, first come first serve scheduling simulator that it will simulate that handles dynamic process arrival time, evaluates the key performance metrics such as waiting time and turnaround time, as I said objective in the introduction. Compare the outcome across the multiple data sets like turnaround time, arrival time, bus time, CT, comparison time, like that. This study aims to determine whether the first come first serve schedule is suitable for a real time environment or not. Next, implementation. Here, implementation or structure like this: processes ID, PID, arrival time, arrival time, burst time, BT, start time as ST, complete time as CT, waiting time as WT, and the turnaround time as TAT. And we will calculate here the waiting time and the turnaround time. For waiting time, we have to subtract starting time minus arrival time. For TAT, turnaround time, we have to subtract complete time minus arrival time. Tested the simulator using three different data sets, generating the Gantt chart and the output table for a performance analysis. Next, I will show the code in the code which has run in the online C compiler. Okay, in this, I have used the C++ program for executing this process. I have, for my better explanation, I have, before only I have entered the process and the arrival time and the bus time. First, we have to enter the number of processes like 4, 5, or 6. Enter arrival time and the bus time for each processor, like P1 bracket AT and BT, like 0, 5. Next, for process 2, 1 comma 3, first process 3, 2 comma 8, and process 4 I have taken 3 comma 6. So FCFS scheduling results are like this. For processes, here are the processes P1, P2, P3, P4 we have taken. The arrival time is 0, 1, 2, 3, and the burst time is 5, 3, 8, 6, which we have taken in the above. Like, see here, the entire arrival time and the bus time for each process we have taken here. So we have calculated the ST, CT, and TAT and WT. For for ST, 0, 5, and 8 and 16. So we have compared this by adding the bus time for each process in the ST. For the CT, 5, 8, 16, 22. So for CT, I have added ST and BT. 5 plus 3, 6, 7, 8. 8 plus 8, 16. 16 plus 16, 22. For TAT, 5, 7, 14, 19. So I have added the CT and SD. ST. See 5, 7, 14, and 15. For waiting time 0, 4, 6, and 30. Here are my output result, and the average waiting time is 5.75 ms. Thank you.